Hey guys, we're just going to run through some notes on 4.4. This is the assignment we're going to do on Wednesday. Assuming that you're not taking the PSAT, I fully expect you to take this. I know there's the SAT, so if you're a senior taking the SAT, you can let me know that you're going to be busy taking that. Otherwise, the expectation is you're doing this. Again, if the PSAT actually does take place on Wednesday, I'll make an adjustment to what's assigned here. But there's not a lot assigned here anyway on 4.4. We're doing 4 through 6 and 8 through 16. That's only about 15 problems. But let's take a quick look at chapter 4.4 and talk about what we're going to be doing. Essentially what we want to do is we want to be able to compare lines based on their slope and their how steep they are, or if they're flat, if they're vertical, horizontal, things along those lines. So we need to have a way to discuss it and compare that everybody will agree on and have the same rationality. And so there's a couple of different definitions for the concept of slope. We typically use the letter M to represent slope in lines, and slope is equal to what we call the rise, how much something goes up, divided by the run. Now, if the rise is actually dropping, let's assume it's actually headed downward, then even though we use the word rise, it would come out negative because it would be negative rise, which can be very confusing when we use the terms rise and run, and sometimes we're dropping instead of rising. So there's actual definition that's a little bit more formal that says if we take y2 and we minus y1 divided by x2 minus x1, we should get the actual slope. So in order to understand this, we have to understand where do these x1s and y1s and x2s and y2s come from. In order to use the slope formula, we have to have 2 points. x1, y1, we're calling this point 1, that's what the 1's mean, and we need x2, comma, y2. We need a second ordered pair, an x and a y for the first point and an x and a y for the second point. In the first few problems, 4 through 6, okay, you'll see that they've given you a drawing where they actually label the 2 points. Once we get to 8 through 16, the drawings are no longer there, but we don't really need the drawing. We just want the numbers anyway. And so what we want to do is we want to try and find the slope in each of these problems. So let's take 2 examples. I'm going to actually start with question number 12 here, and then we'll come back and we'll look at number 5 and some of the special cases that we look at. So on number 12, it doesn't matter which point is point 1 and which point is point 2, but I'm just going to always label x1, y1 first, and then x2, y2 first. So when I use the slope formula, all I have to do is take my y2, which is 1, I subtract my y1, which is 4, divided by x2, which is 4, minus my x1, which is a negative 3. Now this gets people into trouble all the time. Just use parentheses negative 3. Don't assume that this negative in the middle is the negative from the 3. It's not. If I was doing this by hand, I would take this double negative and turn it into a positive. But I know some of you struggle with that kind of arithmetic and you make some mistakes. So one of the other options that's always pretty effective is to just use our calculator. 1 minus 4 is negative 3. So over here, I would have negative 3 over, and then I'm going to do 4 minus, parentheses, negative 3. I just want to write it the way that it would look on my paper, and the calculator should manage just fine. Produces 7. All right. This would be the slope of my line. Now notice it's negative, which means that the slope is trending downward, so I expect this line to drop. If you ever get like a negative 2 over 4, notice that 2 and 4 both divide by 2, meaning that this is reducible. If I divide the top by 2 and I divide the bottom by 2, I would get negative 1 over 2, which would be a better version than 2/4. The other thing that you need to worry about is if you get a negative, say, 3 over negative 5. 3 and 5 don't reduce, but a negative over a negative, we could divide both numbers by negative 1. Those negatives like that will cancel. And even though it started out looking negative, because both of them were negative, it comes out being a positive slope. So those are a couple of simplification things that you might want to look out for. But there are four basic solutions you'll get. You can get a positive number if the slope looks like that. So a positive number. You can get a negative number when the slope looks like that, when the line's dropping downward. So you will get positive numbers, you'll get negative numbers. Occasionally you'll get a slope of 0. And a slope of 0 means that it doesn't go up, it doesn't go down. It's flat. Then there's the slope that's a little weird. What exactly would we call a slope that looks like this? Well, it's so steep that there's no run. It doesn't ever go side to side. This type of vertical line is going to have a slope that we call undefined because it's too vertical for us to measure. Now, how will you know when you have a vertical line? Now, obviously, number 5, it has a picture. The slope's undefined. We can see it's vertical. But in these other points, it's hard to tell. Well, we know that something's undefined if the run of the calculation is 0. In other words, if you get some number divided by 0 when you make the slope calculation, dividing by 0 is undefined mathematically. Whereas up here, when we have a horizontal line, we would get m equals 0 divided by a number. That's okay, and that produces a slope of just 0. But anytime 0 is in the denominator of our fraction, we have to reject that value. It's not something that we know how to calculate. And so we say it's undefined. Those are the 4 different types of answers you'll be getting: positive numbers, negative numbers, 0, and undefined when there is no run in the slopes. All right, good luck. Shoot me your questions on Teams or come into class or email me. I want to help you be successful. All right, we'll see you when we see you. Good luck.